All right, so here's the answer key for the mild page. All right, so the first thing you want to do is calculate the slope of the line, show work, and write the math model. All right, so I want to pick out 2 points that are good. So I'm going to pick 0, 60. Actually, all of these look pretty good. So I guess I'll just pick this one, 8, 120. Okay, so when I calculate the slope, right, I'm going to do the change in y over the change in x. Okay, so I have x1, y1, and x2, y2. All right, so I'm going to have 120 minus 60. All right, that's these guys. All right, and that's going to be meters because that's on my, or centimeters actually. It's on my y-axis. All right, divided by x2, which is 8, minus x1 is 0, and that'll be seconds. Okay, so 120 minus 60 is 60 centimeters in 8 seconds. Okay, so then I'm going to put that into a decimal, 7.5 centimeters per second. Okay, so that's the first thing that you have to do is be able to find the slope. And then remember the units are always rise over run units. All right. Okay, now when I write the math model, I'm going to copy it basically from here. So I have x final equals, that's going to be my velocity, okay, multiplied by the time plus my initial position. Okay, so the velocity is what you just calculated here. So 7.5 centimeters per second. Okay, plus, remember the initial position, that is the position when the time is 0. So in this case, at 0, I can see that the position is 60. So that's going to be plus 60 centimeters. Okay, so that is what my math model is going to look like. All right. What is the object's displacement from 0 to 12? Okay, that just means basically how far it went. Okay, and remember, I'm going to use the final position minus the initial. Okay, and in 12 seconds, this just needs to go a little bit. That's 12. Okay, so that's at 140 centimeters. Okay, and then here it started at 60. So if it ended at 140 and it started at 60, it actually went a total of 80 centimeters during this trip, right? Okay, now this part's a little bit harder. What would the object's position be at a time of 25 seconds? Okay, so this is where I'm going to have to use that model. So I'm going to have my math model. Okay, right, I'm going to have my my math model. All right, and I'm going to now figure out where it's at 25 seconds. All right, so to do that, I'm just, the x final is what I'm looking for, the position at that final time. So I'm going to have 7.5 centimeters per second, okay, multiplied by 25 seconds. I'm plugging that in for the time, okay, plus 60. All right, and then don't worry so much about the units, like if it's freaking you out, right? It's all right. Okay, so I'm going to have 7.5 times 25. So that's going to give me 187.5 centimeters because it's a position. See, those are going to cancel out. Plus 60 centimeters. And that's going to give me 247.5 centimeters, right, would be where it's located at that time. Okay? All right. Okay. All right, next one. Given the position graph at left, describe the motion of the object. All right, so we want to say the object starts at a position of 30 meters and moves. Okay, now I got to decide if it's slow or fast. All right, so this one, that's my negative direction. And that's my positive direction. Okay, so the green line is steeper, right? So I would say, and moves quickly in a negative direction. Okay, then slowly in a positive direction. I hope this all fits here. It's tight. Okay, all right, and you can add extra stuff like the velocity and whatever you want to do like that, but you don't have to. Okay. All right, if I want to find the velocity, okay, on a position graph, right, I'm just going to find the slope. All right, so you can do it any way that you want. All right, you can use the points like I did before, or you can do kind of like this triangle way. So I'll try that this time. So from 30 back to 10, I know it's going to go negative 20 meters. Okay, and then from 0 to 10, it's going to go for 10 seconds. Okay, so the negative is going to be negative 20 meters in 10 seconds. So the velocity is going to be negative 2 meters per second. All right, and then if I want to look at the next one, right, I see here from 10 to 25, that's 15 seconds. And it's going from 10 to 25 here, so that's 15 meters. That was easy. Okay, so 15 meters in 15 seconds is just a velocity of 1 meter per second. Okay. All right, now if I want to put that onto my velocity graph, right, I only have 1 and 2, so that's really convenient. So let's just label this 1, 2, 3, negative 1, negative 2, negative 3. Okay, and then the breaking point happens at 10 seconds. So I know that's where I'm going to shift to my new velocity. So the first one is going to be a velocity of negative 2. All right, up until that breaking point. And then after that, for the next till 25 seconds, it's going to be at positive 1, like that. Okay, all right, so that's what my velocity graph would look like. All right, and then the last part, given the velocity graph, describe the motion in words. Okay, so this is velocity, right? So this is telling me, the first one, the object moves at a positive velocity of 12 meters per second, okay? I could say for 9 seconds, right, if I want to do that, okay? Then stops, and I could say for 9 to 5 seconds, but you don't have to. Then moves in a negative direction at, okay, negative 16, centimeters per second. Sorry, it's not meters, centimeters. Okay, all right, so remember, when the line is above the x-axis, that means it's moving in a positive direction. When it's below the x-axis, that means it's moving in a negative direction. Okay, and this one, since it's on 0 right here, right, that means it's stopped during that part. Okay, if I want to find the total displacement on a velocity graph, I'm just finding that area. Okay, so this is 12 centimeters per second. Okay, and this is 9 seconds. All right, so 12 times 9, 12 times 9 is 108 centimeters in this box. Okay, this one doesn't have any because there's no box because it's on the line. All right, and this one, 14 to 20, that's 6 seconds, and negative 16, so 16 times 6, that's negative 96 centimeters, right, because it's below the axis. So if I add those up, remember, with the displacement, I want to include the negatives, so 108 plus negative 96, or minus 96, okay, means overall he went 12 centimeters.